Hey guys, so today's lesson is about simplifying radicals. You might know radicals as square roots, and this is a setup lesson when we're going to be using these radicals later on to solve quadratic equations. So the objective is to simplify radicals using numbers and using imaginary numbers. So we're going to be talking about imaginary numbers also. What I mean by simplify is when we have something like the square root of 180. Oftentimes you guys will take a calculator and plug it in and you'll get a decimal. Well, decimals aren't acceptable when it says simplify. We need to break down the number. Now, what helps us is knowing the perfect squares. Perfect squares are just like 1 squared is 1. So if I take the square root of 1, I get 1 back. Okay, square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So those give me nice numbers with no decimals. So if I recognize perfect squares, I can automatically take the square root. I have no decimals. Now you should definitely copy down this list and make sure you have that as reference because it helps you in breaking down these numbers. Now there's 2 ways you can do this and break it down. The first way is a little bit longer and requires you just to know what numbers multiply to 180. Well, I can break this down. Okay, and we've broken down these before. When factoring trinomials, we make a little tree. But now we're going to keep all those numbers. So square root of 180, you might say, okay, that's 18 times 10. Well, 18 and 10 are nowhere on my list over here, so they're not perfect squares. So now I keep breaking them down. I just make my square root bigger. So 18 can be broken down into 9 times 2. And 10 can be broken down into 2 times 5. Okay, that's getting somewhere. That's what I want. Because you can recognize this 9 here is a perfect square. 9, the square root of 9 is 3. So I can actually take that out of the square root because I can actually find that square root. Or what I have most kids do is I can break down the 9 even more. 3 times 3 times 2 times 2 times 5. Well, the reason why I break it down more is because I'm actually looking for pairs. Okay? So 3 times 3 is 9. Okay? I have a pair of 3's. I know if I multiply those pairs, I get 9. I can take the square root of 9. So for each pair of numbers that I can take one of them out of the square root or the radical. I can also do the same thing with this pair of 2's because 2 times 2 is 2 squared. Okay? The square root of 4 is 2. So I can actually take those out. This 5 doesn't have a partner, so therefore it has to stay in. So what happens is it becomes 3 times 2, and then inside the square root is 5. So 3 times 2 is 6 square roots of 5. And that's my answer. No decimals. I just made the square root a lot smaller. Now, the other way of doing it is to break this down into perfect squares. So I look at 180 and I make kind of the factors. And I go, okay, this is under the square root. So I could do the square root of 1 times 180. Well, that 1 times 180, that doesn't help us anymore. I'm just generating a list. Okay, that doesn't help me. 2 times 90. Those aren't perfect squares. Not going to help me. 3 times 60. Neither one are perfect squares. Not going to help me. 4 times 45. Neither are perfect squares. Not going to help me. 5 times 36. Oh, 36 is a perfect square. The square root of 36 is 6. So what I can do is I can say, okay, well, I can find the square root of 36. I can't find the square root of 5. So my answer, I would break down 180 into the square root of 5 times 36. Now I can find the square root of 36, which is 6, and then the 5 has to stay in there. Now, oftentimes, this gives you the correct answer all the time. This, oftentimes students make the most mistakes with. So my advice is to break down numbers and look for pairs. Okay? So you could have also noticed here that I have a pair of 2's up in this area that I can just carry down. Once I recognize that I have pairs, I can actually take those out and then continue breaking down the number. It makes it sometimes a little bit easier. My second example is the same basic process, only now it has an A and a B and a C. And most students just freak out when they see any type of variables. Again, let's just look at the number first off. Okay, 120. Let's break this down. 120, and I'm going to break it down over here because I'm also going to break down the letters. Okay, 120 is really 2 times 60. Well, that doesn't really help me. So now I'm going to break that down into 2. Again, I'm not going to break down the 2 because I'm just going to get 2 times 1 and I'm just going to keep cycling back. Really, once you get a prime number, you're done with that number. You just have to carry it down. So this is going to be 2 times 30. I have a pair of 2's. But let's keep going real quick. 2 times 2 times 15 times 2. Okay, well, we can break down the 15 a little bit more into 3 times 5 times 2. So you'll notice that I have one pair of 2's, and then these don't have pairs. Okay, I do have 3 2's, but I'm only looking for pairs. So I'm just going to take 1 2 out. What stays in the square root is this 3 times 5 times 2. 3 times 5 times 2 is 30. I just multiply those out once I'm done. Now, let's look at the variables. A squared. A squared is really A times A. Okay, so it's A times A. Okay, I'm skipping all the way down here. This is a pair of A's. So, for every pair that I can make, I can take 1 on the outside. For b to the 5th, it's really b times b times b times b times b. 5 b's. How many pairs? 2 of them. So 2 b's come out. B squared. One of those b's stays in because it doesn't have a buddy. And the last one is the c. C, there's 4 c's, which means I have 2 pairs of c's. So 2 c's come out, and there's none left in. So all you really have to do is break down the variables in pairs, or divide the exponent by 2. So if I can look at this, a squared, if I take the 2, divide by 2, I get 1a on the outside, and none left. 5 divided by 2 is 2 on the outside, 1 on the inside. And 4 divided by 2 is 2 with no remainder. So that's how I break down variables. So I'll do a few of these too. So 28, square root of 28 with just the number. Again, I break down the number into its parts. You might say 4 times 7. And some people might be able to go, oh, well, the square root of 4 is 2. And immediately jump to my answer, 2 square roots of 7. Some people might need to break the set of 4 down into 2 times 2 times 7. Again, I'm not going to break down the 7 because that's a prime number. And the only number is 7 times 1. And it just, once I'm timesing everything by 1, I don't need to break it down anymore. You'll notice I have a pair of 2's, and you take them out. For 60, the square root of 60, again, I can break it down into, I always like to make big jumps. 6 times 10. Okay, I don't like to break it down 2 times 30, 2 times 15, that sort of thing. I like to make big jumps. Because then I can break this down into 2 times 3 times 2 times 5. Well, you'll notice that I have a pair of 2's. They're not next to each other, but they're still inside the radical. That's still a pair. So I can take a 2 out. What's left is a 3 times 5. Well, 3 times 5 is 15. So that is my final answer. No decimals, just breaking down the numbers. For 9, with the variables, again, I can break this down into 2 times 2 times a times a. Well, I have a pair of 2's and I have a pair of a's. So both of them come out. So it's 2a. And because both of them came out, there's nothing left in the radical. This is my final answer, just 2a. You can end up with an answer that doesn't have a radical. For 11, I just wanted to talk about this 300, because if you recognize it as 3 times 100, and then break down the 100 into 10 times 10, I actually don't have to go down any further. So oftentimes, students will break this down into 2 times 5, 2 times 5, create another step for themselves. But the biggest thing with radicals is I'm actually looking for pairs. I have a pair of 10's right here. Once I find pairs, I can automatically take them out. 10 inside the square root is a 3. Now I've broken down the number. I can't break down 3 anymore. I saved myself some time. 8 to the 4th, I can take that 4, divide by 2, because I'm looking for pairs of things to help leave the radical. 4 divided by 2 is 2. And it goes in evenly, so there's no a's left in here, and this is my final answer. You can always write these things out in circular pairs. So you just have to recognize what ones go together. The only tricky problems come in problems like 6 and 7 and 8. I'm going to leave you to do 8. For 6 and 7, the first thing I have to do is I have to put them together in the same radical. So I'm going to write 3 times 6. Now I'm not actually going to multiply them. That's oftentimes where students make a mistake further on. It's not going to hurt you now, but it will hurt you it'll hurt you in the future. Now I start breaking down the numbers into 3 times 2. Now I have a pair of 3's that I can take out. 3 squared is 2. Again, I don't multiply, I just start breaking down. Here, for 7, I do 2 times 5. Well, I can't break down 2 anymore. I can't break down 5 anymore. So I'm actually done. I can't take anything out of there. So I leave my answer as the square root of 10. 2 times 5, which is 10. That's my answer. All the rest of these problems are little practice problems that you should be working on and come in next class with these answered. Again, sometimes you're going to have no square root, like this one. You're going to end up with just 9x squared y with no square root in it. Well, in this one, you're going to have some square roots, where you're going to have 5ab square roots of 6c. That's the answer that you should end up with, because you break down the number and then you break down the variable separately. In the next video, we're going to discuss how to do this. And this is where this imaginary numbers comes in. It's the same process, only now you're breaking down the square root of a negative 49. Typically, if you plug that into a calculator, you're going to get an error, because there's no real answer. So what happened was mathematicians ended up with these answers when they were analyzing nature a lot. So they had to create their own number system. So they created this thing called imaginary numbers. So the true answer to this, the square root of 49 is 7. And the square root of -1 is I. So after you've done practicing your radicals, check out the next video on complex numbers. Thank you.